take another deep breath. Let it out. What do you breathe in? That's a trick question because really your body uses oxygen, but you breathe in whatever's in front of you. Any of the air is in front of you, and most of the air on Earth is not oxygen. It's not carbon dioxide. Most of the air on Earth is, who knows? Everybody say nitrogen. Most of the air is nitrogen. Now, this is important. If you are in your kitchen and you're heating up water on a stove, what happens to it? It bubbles. It starts to bubble and turns from a liquid into a, say, gas. Yeah, evaporates, turns into a gas. If you take that same gas, that same water vapor, and you cool it back down, it goes from a gas back into a liquid. Okay, so here's what we did. We took all this nitrogen and cooled it down, cooled it way, way down, and turned it from a gas into a, say, liquid. Liquid, yes. And we made, say, liquid nitrogen. Yes. And it's kept in this big thermos-looking thing called a dewar. This is liquid nitrogen. I'm going to dump stuff out. What color is it going to be? Clear. What color is nitrogen now? It's clear. So we're going to dump this out. I'm going to pour it out.
Oh my God.
What would happen if you touched one of those little bubbles? Actually, not really, because your skin is so hot, it would instantly turn it to gas. Now, if you see, can you see if you can see? You'll see the smoke. You see the little bubbles also? Little bubbles like that, yeah. It's like when you put like a few droplets of water on a really hot skillet. That's the same effect because it's so cold in here, negative 321 degrees, and it's so hot out here with the pavement. Now, like I said, we're going to turn this from a liquid into let's turn it from liquid back into a gas because you can see it turning into gas right here. If you want to speed up that process, just like that. Now, when people get really cold, they get close together. Take one step towards the middle. Take one step towards the middle. Take one step towards the middle. Okay? They get closer together. Just like air molecules, they do the same thing when they get cold. Now, when people get hot, wait, we're hot, spread apart, spread apart. When you're hot, you don't want anybody near you, you want your own space. Just like air molecules when they get warm. Wait, we're cold again, step one forward. See, when we're cold, we get together, and we're hot, spread apart, spread apart. Everybody got it? Hey, how many balloons can I stick inside my bowl? One. If I add nitrogen, oh, it's okay, I've got more. Oh, by the way, what should I probably be doing about now? Gloves, yeah, is this cold or crazy cold? Crazy cold, so I'm going to use some gloves here. Now, here, give me a balloon. Balloon. What's happening to my balloon? It's shrinking. Other balloon. Give me more balloons. Go. It's shrinking. Remember our little demonstration? What's happening to the air molecules? When air molecules get cold, they crush in together like that. Balloon. So the balloon isn't popping. It's still there. All the air is still inside. It's just getting really, really close together. How many balloons can we fit in here? All of them. Probably tons. Probably a lot if they didn't already run away. Okay. Actually, don't worry, I still need you. So here, take this and put this on your left hand. Take this and put it on your right hand. And come over here, please. Hold your hand out like this. Like this. Now, all the air, I'm obviously not touching the nitrogen, otherwise I'd be totally screaming. All the air is in there. As it warms up, it starts to reinflate. That's just the air molecules spreading apart. Because I need you to hold that. Hold. Now, if you blow on it, it'll happen quicker. And we're going to go out here. Here, blow on these. Yeah, and that'll happen invariably. When you get it cold, the air molecules go together. When they warm up, they spread apart, and it appears to reinflate. And that's good enough. Give my balloon wranglers a round of applause for coming up and doing that. Balloons, run for your lives. Okay, so you recognize this is the balloon just filled with normal air, but you've probably seen these at your birthday party where they float in the air. Those are helium balloons. Now, you might have seen the blimp, that big ship that flies over football games and takes pictures. That's filled with helium also. It's filled and then it floats in the air really nicely. But a long time ago, they didn't use helium. They used the lightest gas we have, which is lighter than helium. They used hydrogen. Hydrogen is the #1 lightest gas we have, but they don't use hydrogen for blimps anymore. I Wonder why. Let's find out. Hey kids, welcome back. Now the question I get asked most frequently when I come somewhere is, hey Science Wizard, are you going to blow something up? Well, of course, that's why I'm here. But today's segment is all about kitchen science, things you can do at home. So do not do this at home. Don't try this at home. But I am going to blow something up with ingredients I found right here in the kitchen. Our first ingredient is, let's see, this is aluminum foil, tin foil. If you're really old, you might call it that. I need some of this. So what I'm going to do, take off some tin foil and just crumple it up in some little balls. I'm going to need the aluminum for this next reaction. And next we have NaOH, sodium hydroxide. This is drain cleaner. It's lye. Let's see. We're going to add some lye. What did we learn about measuring our ingredients? We should always measure? Well, whatever. Okay, dump some in there. Oh, that reminds me. Nah. Hey, have I been wearing safety glasses yet? No, but I'm wearing them now. What does that tell you about this next demonstration? Let's see. So, safety glasses on. We've got the sodium hydroxide. And put that in there. Now, we're going to add some water, H2O water. Now, this is going to give us an exothermic reaction. Exothermic means it's giving off heat. So I'm going to dump that in there. And that's only a little bit. I might need some more water. Get my emergency reserve of water, just for fun. That's probably good. Now, swirl this up. Oh, that's really warm. This is giving an exothermic reaction. It's giving off heat right now. Pretty soon it's going to be too hot to touch. So we're having this reaction right now. And it's hot at the moment, but it's going to get really hot. Let's see. Yes, and, here we are. Gloves, safety gloves, because safety is, my number one priority. It's in the top 5. It's up there, but it's significant enough that I'm going to wear these gloves because it's going to be super hot. Now, let's see. I've got the sodium hydroxide, and now it's time for... All right, get the foil. Get in there. Now, oh my gosh, it's starting to bubble. I need this glove on because I got to put this balloon on. It's starting to bubble. Now it's giving off hydrogen gas. We are making a hydrogen balloon. And oh my gosh, that's happening so fast. I didn't think it'd go this fast. I'm putting on gloves because that's going to be not just hot, but crazy hot. And, okay, now, I got to tie this balloon, which I can't do with gloves on. Ouch. Hey, is it hot or am I just teasing? It's crazy hot. Look at that thing bubble. Okay, so now we got to blow. Oh, here. I need here. Disembodied hand. Come here. Get over here. Quick. Okay, here. Now we're going to take this up. Remember, this balloon is filled with hydrogen. Remember that blimp? Let's see. This is why we don't use hydrogen in our blimps anymore. Let's bring this. Come on, coward. Bring it all over here. And... it's not working. Okay, what a fun game to play. Don't try that at home. Oh my gosh. Thank you so much. Whoops. Somebody get the ceiling. We'll be right back. Hey, by the way, should you touch the nitrogen? No, it's a terrible idea. And to prove that, I've got my brave volunteers who wants to be a volunteer to touch the nitrogen. Oh my gosh, you don't want to touch the nitrogen? Which is why I'm using, say hi, Beach Ducky. Beach Ducky can't go to the beach anyway, so in you go. And I don't know what kind of ducky this is. This is, Pirate Ducky. Pirate Ducky, in you go. And let's get more nitrogen in there. Hey, once again, chemistry, do we measure it or just dump it in? Dump it in. That's kind of what we're doing here. That's a lot. Now, hey, what am I doing now? Have I been wearing glasses yet today?
No.
But I'm wearing them now. What does that tell you about these experiments? Yes. Also, we have bouncy ball and oh, I forgot. I was going to ask for some fruit, but I don't need fruit because I have my sweet, beautiful roses. In you go, roses. Now, this is getting really, really, really cold. Am I really cold? I mean, so cold I don't want to touch it. Now, anybody ever watch any of those competitive cooking shows? What just happened? A ducky exploded. That's what happened. Sorry, ducky, who exploded. It was the pirate ducky. Sorry, pirate ducky. In those shows, they have a blaster that gets something really cold really fast, and they don't do rubber duckies because they shatter. Okay. It only takes a few seconds, really. Oh, look at my nice, pretty rose. I skip now. Ah, it explodes. Look out! Who wants an exploding rose? Exploding rose! Ah! Here we go. Exploding roses! Ah! Oh, my ducky. Sweet little beach ducky. Now, the other pirate. Okay. Who's going to win the battle between Mr. Ducky and Mr. Hammer?
Oh, okay, obviously.
Well, let's see. It was the hammer. Oh, my gosh. I forgot the main course. Everybody say hi, Giblets. Say bye, Giblets. In you go, Giblets. Get in there, Giblets. And one more time for Exploding Roses. If you want to explode rose, get up to that line right there. That's good. Actually, get up to this line right here. 3, 2, 1. Ah! Look out! It's raining roses. Somebody squeeze them. Destroy them. Okay, back to your seat, back to your seat, back to your seat. My roses!
It's so cold.
I'm going to need a broom after this. Okay.
Oh my God.
What else is in here? Who remembers? Bouncy ball.
Yeah. Oh,
Ah! My bouncy ball. Yeah, you can see these things get so cold, they get all brittle and they shatter. Ah! I think that was the chicken. Sorry, Giblets. Oh, wait. What? Ah! My chicken! Ah! Okay, you get out here. Okay, now most of the things are made really brittle, but what's this? Now, this made it real, there's a lot of liquid in there, so it made it hard and strong. It's so strong, it's as strong as this device. Everybody say banana hammer. It's such a strong hammer, strong enough to hammer this nail in this piece of wood by just being a banana.
Oh my God.
Ah! That, totally, oh, whoops. Well, if you run out of hammers, that's why you do that, so you just use your banana. Oh, you can see right there, it still hasn't frozen through. So if you stick your tongue right in that spot, you wouldn't get frozen. Who wants to try? Oh my gosh, what's wrong with you? That's a terrible idea. If you missed, then the rest of the banana would do what? It would freeze and stay on your tongue, and you'd have banana tongue all day long. So you don't want that. And now one more thing, what's left in here? Get up. Oh gosh. Giblets. Okay, we're going to do it right here. And give me a countdown. 5, 4, 3, 2, 1, and... Ah. Final quiz. What's this stuff? Liquid what? Say nitrogen. It's really cold. How cold is it?
Really cold.
Really cold.
Crazy cold.
I don't use Celsius. I'm not Canadian. Yes, negative 321 degrees Fahrenheit. And let's see, where's the wind blowing? Right towards that guy.
Yeah.
Is that good or bad? Bad or terrible, probably. Let's see. Terrible. Let's see. Well, now it's blowing towards me. That's even worse. There's really no good way to do this. Okay. What was the first thing we did with the nitrogen? Who remembers?
Hot water.
Hot water, turning it from a liquid into a, say gas. Okay. So take a look at the smoke, see which way the wind blows, and which way should I run for my life? That way? Okay, here we go. Give me a countdown in 5, 4, 3, 2, 1. Ah! Yes! Come up to the line, come up to the line.
No way.
Quick, now blow inside. Don't put your hands in now. Blow inside and blow your face off. Isn't that cool? Oh my gosh, my chicken carcasses. Leave it there. It's yummy. Weird. Yeah, if you blow straight in like, ah! Ah!